right. Hey, everyone. I'm excited to be here and talk to you about Golang security in Go modules. So I'm going to basically do a really brief introduction and talk a little bit about myself. And then we're going to talk a little bit more about the history of dependency management in Go. And I'm going to dive into what changes came with Go version 1.13 Go modules. I'm going to go over a few brief checksum database concepts that'll help us get some context for how vulnerabilities are scanned in Go Center. And then I'll walk you through a bit of a scenario where we're going to be committing a new module to the checksum database. Then I will actually demo vulnerability scanning in Go Center, as well as showing you a demo of how it works in VS Code when you're building a project. And then we'll end with some Q&A. Cool. Right, so to get started, a little bit about myself. My name's Data, product manager at JFrog. My role is actually really fun. I get to basically work on free and open source projects that are, directly for kind of your developer. I'm always interested in learning directly from people on what they're working on. I manage JFrog's centers, so Go Center and Conan Center and J Center. But obviously today we're going to talk about Go Center a little bit more. I put up my email and my Twitter account right there, so please do reach out to me after this webinar. I'm pretty easy to get a hold of, so feel free to email me. I'll get back to you in like 48 hours, or definitely you can tweet at me. I check Twitter like every day. So cool. Let's dive into the webinar content. Okay, so first thing I'm going to talk about is a little bit of the dependency management history of Go. So you probably know that Go has gone through, a few different dependency management sort of processes. We started with Glide, and then, there were some things around putting your dependencies in your Go path. Next, Go experimented with a dependency management tool called dep, which is probably my favorite because it's one letter away from deep. and of course, we had vendoring. So as the community evolved, Go, basically went through an evolution and realized that there was a better way to manage dependencies. And in Go 1.11, Golang introduced the idea of Go modules. So Go modules, a module really is just a collection of packages stored in a file tree, and they're put in your go.mod file. And we're going to talk a little bit more about the go.mod file. And then with Go 1.13 released in September of last year, Go modules basically became the official standard way to manage your dependencies. So what I really like about Go modules is that they introduced some pretty basic but pretty important security and data integrity sort of features into how you build your projects. So you might know this, but basically, when you do go mod init, a go mod file is created, and the go mod file has a list of all your dependencies, and another file called the Gosum file actually creates a bunch of hashes, and we'll talk a little bit more about what the hashes do in the next slide. So your Gosum file basically has a series of hashes, a list of hashes, and these hashes are used as checksums. So they're basically used to check that your data is intact. So whenever you are importing a Go module, the Gosum file is checked, and if the hashes match what's in the Gosum database, it ensures that the data integrity is intact, that nothing sort of failed or broke in transmission. It's also a good way to check that there wasn't any malicious sort of code introduced at a later time when you're importing this module. So Go really thought through this process with the checksums And what I want to do is actually walk you through some of the core concepts for how checksums work in Go. So Go uses the SHA-256 based hash, and SHA basically stands for Secure Hash Algorithm. So how it works is whenever you create a file, whether it's a plain text file, an image, whatever, and you put it through the hashing algorithm, what comes out on the other side is the actual hash, right? And Go uses the SHA-256 base 64 hash, which will always spit out 43 characters, right? So no matter what you put in as the input, the output is always going to be a 43 character string. And what's really cool about these SHA-256 hashes is that they're unbreakable. No one's ever broken one yet, and they are unique and irreversible, right? So you can't have the hash and put it back in and understand what the file was at the beginning. The way the cryptographic mathematic works out, you can't go backwards. So they're irreversible, which is really good for security, and they're unique. So if I have a file and it goes through the hashing algorithm and the output is this 43 character string, I can change one character in that original file, and what will come out of the output will be another 43 character hash, but it'll look completely different. So there's no way to actually match these hashes up and understand sort of what data went in at the beginning. So the way the hashes actually work in the checksum database is, Google basically takes the hashes in your Gosum file and stores them. And they're not stored in a normal database. They're stored in a Merkle tree, which you may be familiar with if you've ever looked at how blockchains work. So the data is stored sort of here at the bottom node, and then the hashing algorithms spits out a checksum for that piece of data. And these checksums are then combined, and they go through the hashing algorithm and spit out another hash all the way up to what is called the root node. So what I think is really cool about this is Go wanted to make it very easy to see if any piece of data was was changed. So whether that was changed by some malicious attack, or maybe just data transmission, if the data integrity was changed. The Merkle tree and the hashes really help us understand what happened and where it happened, right? So if you actually made a change in any of the data, you'll see that it actually changes the hash all the way up that branch of the tree, and the root will be a totally different hash. And Golang basically uses the root to verify your module at the end. So this is actually a really smart way to make sure that the data, again, the data integrity is intact. All right, so how does this actually work in the checksum database? If I have two Go modules, module 1 and Go module 2, each individual module has its own go.sum file, and I can use the Gosum file to verify, that these modules are the same ones that I am importing from the checksum database. So when I first create my module and I run it, it actually gets stored in the Golang checksum database called GosumDB. And that list of hashes in your Gosum file gets committed to the database. So again, the database is a way to check the checksums, and anytime somebody commits their module to the database, it gets stored there. The one issue with this checksum database process is that it's mostly used for file integrity. It's not a linter. So, if you have a security issue or a vulnerability in your Go module, the database is not going to necessarily know that. You can commit, any relatively bad code into your module, and it'll get committed to the checksum database. So What the checksum database really does is keeps your data integrity intact, and it ensures that if somebody pulls down that module at a later time, that the checksums match. So the way the hashes will protect you, again, is if I have my module 1 and it's got the Gosum file in it, and then someone else comes along and downloads my module 1 and they make any kind of minor content change, what'll happen is if they're trying to commit that exact same module with their change to the checksum database, they're going to get a checksum mismatch error. It won't actually be committed to the database if they're trying to commit it under the same name, right? So this is really smart because this means that someone who is trying to basically do something malicious with your module, that is not going to be stored publicly in the checksum database. And when you try to import this module later, you won't get the one that's been changed. You'll get the one that was committed originally from the author. Okay, so to give you a bit of an example of how this might actually work if I'm building a module. So let's say you create your first Go mod as mod 1. So here I've got my main.go file in my, and that file basically gets created and the Gosum file gets created, and when I run this, it gets stored in Google's checksum database. But as you can see, I actually made a mistake. I imported the text/template dependency, and I actually meant to, I'm building a web app, so I actually meant to use the HTML template. The text template will actually open me up to a cross-site scripting attack. The text template is not encrypted. So if we go back and we look at the original module that I committed, oops, here we go. Again, this module is going to open me up to a cross-site scripting attack. So what do? So I take my file and I update it, and I import the right dependency, the HTML/template. So what I need to do now to let Golang basically know that this happened is I need to save this file as a new version. If I'm making a minor change, I would basically save it as a patched version. And if I'm making major changes to my file, I might save it as a v2. So what's important to know when you're saving your new version is Golang uses something called semantic import versioning. Basically, if I have a patched version, the version number changes in the decimal places to the right of the v1, and this can be imported in my import path as shown right here on the top line. Now, if I create a second version, a v2, you're going to see there's a slight change in how the syntax is for that v2 import path, right? So now it's libfoo/v2. Go is very strict about this, and here at JFrog, the Go Center team sees a lot of issues with versioning. So make sure that when you're updating your version, you're paying attention to the semantic import versioning. Cool. Okay, so now that I have my module 1 and I've got my mod 1 version 2, these modules basically have a different Gosum file, a different list of checksums. So now when I commit this to the checksum database, they both pass, which is good. That's what we want. So if someone imports mod 1, though, they're going to open themselves up to a cross-site scripting attack. So in the real world, this, as we're building our Go projects, you're going to see this a lot. People are importing older versions of a module. They may not know that a new version exists. And with a growing list of dependencies, you can probably imagine how this becomes a big problem in keeping your modules secure. So how do you actually know that a new module version is out? That's actually what I'm going to get into by talking a little bit more about Go Center. So to summarize so far, we have our Gosum file that lists that has a list of all your checksums. and then your Go mod file stores the list of each dependency and each version of that dependency. And the hashes are then there to detect any misbehavior or any changes in the data structure. But like I said before, the vulnerabilities that might have been accidentally put into the module at the beginning, they will be committed to the checksum database. So how do you get around this? This is where I get to talk a little bit more about GoCenter. So GoCenter, just to give you a little introduction, is a Go proxy. It's totally free for the community. And GoCenter actually has more than 700,000 Go module versions and counting. GoCenter periodically scans the web for new modules and new module versions for anything that's publicly available. And it's a great module mirror that you can use to keep your Go modules secure. So you can actually set your Go proxy to GoCenter using that command at the bottom, export Go proxy, and then gocenter.io. And what I'm going to do is give you a little demo of GoCenter. So I'm going to go ahead and share my screen. All right. Cool. Okay. So let me move my screen a little bit. So here we've got GoCenter. It's gocenter.io. And I can basically come here and I can search for any public module. So if I want to search for, Kubernetes, I can do that. What you're going to see is you're going to see the name of the Go module. You'll see a brief description. You will see the latest version, whether that's a major version or a pseudo version. You'll see the number of downloads and you'll see stars. Here on the GoCenter page, we have a lot of metadata, stars, license downloads, mod file, security, which I'll get to in a minute. We've got dependencies and imports, some metrics. So as you can see, GoCenter actually has a lot of metadata around each Go module, and it even has basically every version available, including pseudo versions. So what I want to show you here on GoCenter is actually the security tab. So Kubernetes, this version of Kubernetes, which is the latest, has two vulnerability issues, and we basically use JFrog's X-Ray, which is our premium security tool, to provide this information for you for free. And on the security tab for every module and every version, you're going to see the CVE ID. You will see the severity level of the vulnerability, and you'll get a description of that vulnerability as well. So this CVE information, this is the common vulnerabilities and exposures list. This is a publicly available list managed by the Department of Homeland Security, and it basically gives you a view into all the reported issues for, basically any Go module. Cool. All right. So now that I've given you a little bit of a view of GoCenter, what I want to do now is switch gears, and I'm going to show you how the vulnerability scanning actually works when you're building a project in VS Code. So I've actually got little apps started here. So what I did in my Go module, in my Go project, is I wanted to learn how to build a simple web application. So here I've got an order book. I've created a way for my parents to order groceries that I can go and pick up for them. So I'm going to go ahead and just run this and show it to you in the browser. Okay. All right. So here I've got my my application that I'm building in VS Code. It's a grocery app, and what I can do is I can add items here, or my parents can add items. So if my mom wants to order some salsa from the grocery store, she can add it to the grocery list app, and she can she can tell me that she wants mild salsa, and you'll see that I've got the total items, and I've got the grocery list. As I started building my web app, I soon realized that I don't have a database connected to this. So these 3 items that are being added, these items are being stored in just a basic text file, right? So if my dad is ordering chips, it'll get added to the text file, but I don't have a database where I can really store this information permanently and separate it out so it's not just listed in one row. So I can show you that in VS Code. Oops. Right now, this data is being stored in a text file. So what I did after this is I went online and I wanted to understand how I could build a simple database for my web project. And I found a cool tutorial online around using an ORM, the Object Relational Mapper, to basically spin up a SQLite database for my web app. So I'm going to show you that next. Here is my ORM project. In this ORM tutorial, what it's asking me to do is to import a third-party dependency called GORM, and really popular ORM relational mapping module for Go. And here you can see I was able to take the 3 entries in my web app, which was the name, the order, and the message, and build out a SQLite database using the GORM module. And I'm going to go ahead and I'm going to spin this up so you can actually see it a little bit. Okay, so my GORM project has started, and using Postman, you're going to see that I actually have a bunch of database entries already in there. So I've got the name of the person who is requesting the grocery item. I've got the order, which is here is a taco, and got a little message that they can put. So my sister wants us to make sure we order some chicken tacos. I can also post to my SQLite database. So if I want to add dad, and dad wants, let's say he wants milk, and my dad likes to drink soy milk, I can actually send that to the SQLite database. You're going to see that entry has been created, and then I can go ahead and I can actually look at all the entries, and you will see that my dad's entry has been created. Here's his name, here's his order, and here is the message. So as I was building out the ORM project for the back end of my groceries app, I started exploring the Gosum file. Here I saw all the checksums, all the list of hashes that are being checked against the Gosum DB. So as you can see, there's a series of them right here for every dependency in my project. And when I went to my Go mod file, what I noticed is because I have the JFrog extension installed that has Go's free vulnerability scanning, I saw this red underline under the GORM dependency. When I basically moused over it, I got these details from Go Center saying that there's one high vulnerability. I'm also here able to see that there's a license, MIT license. There's a little description of this module, and it's showing me like the latest version and stars and some other information. But of course, the little red underline was my biggest concern, and seeing that there's one vulnerability, I clicked on this little light bulb, and then I clicked on Show Dependencies. I'm coming over here to my JFrog extension. I can actually see all the dependencies that are part of the GORM module, right? So anything that the GORM module is dependent on will show up here in my component tree. And then here I can actually see all the issues that are present in this version of GORM. If I click on view CVE in GoCenter, I can actually go to GoCenter and I can see this specific module in this version show up on the GoCenter security tab. And again, here it lists the CVE ID. Issue high, and the description says that GORM before 1910 allows SQL injection via incomplete parentheses. So obviously that's bad. What I want to do is I want to see I want to see basically if there's a version of GORM that doesn't have the vulnerabilities. So what I can do is in GoCenter is I can come over to the versions tab, and I can see all the pseudo versions and major versions, and as described in the CVE description, these older versions of my GORM dependency have vulnerabilities, but newer versions of GORM do not. So basically what I would do next is I'd probably look for a new version of this module, 112, and I'd pull it into my application in VS Code. One really fast way that I can do that is I can actually use GoCenter as my Go proxy and then go get this dependency. So if I stop my app for a second and I go to GoCenter and I copy this command line text and I can put it into VS Code like that, I am now pointing to GoCenter, and I can actually go get a new version of this dependency. Let's see that right here. Okay, so as you can see, I am now importing that dependency as well as some of the transitive dependencies right into my project. If I do go mod tidy, it'll actually clean up my go mod file. If I save that, you're going to see I now have a totally clean go mod file, and my dependency list is totally clean. So this is basically how I would use the JFrog extension when I'm building out my Go app. And other things you can do with this is you can actually see, the full metrics in, you can see the full metrics in GoCenter, and you can also view the README. So if I want to do that, open up GoCenter. Right. So what vulnerability scanning in GoCenter really allows me to do is build out my Go projects in a safe way. As I said, the versions tab lists all the versions of every single module, and using the Go proxy command, I can go get the latest versions of all my dependencies. Cool. So going back to my presentation, what I want to do now is just wrap up and tell you a little bit more about what we're doing next with GoCenter. So basically, as I showed you, you've got your vulnerabilities on the security tab, and you've got every module and version. And if I want to see what versions are safe, I just go to the versions tab in GoCenter. Cool. All right. Okay, so the tutorial that I just showed you today is actually available if you want to go to this link right here. I also don't want to hate on Go ORM too much. It's a really cool module. So you can go to gorm.io to pull that up. And the last thing I want to do is I want to tell you a little bit about the next swamp up that is coming up. So I'm going to go ahead and share my screen one more time. If you're interested in learning a little bit more about JFrog and how GoCenter works, definitely check out Swamp Up. We're bringing it to you online this time, 23rd and 24th. And then we're doing one in EMEA, June 30th and July 1st. You can actually go to the link, which is, sorry, here we go, swampup.jfrog.com, and you can sign up there. Okay. All right, so that's basically my presentation. I'm gonna go to Q&A now and see if you guys have any questions about vulnerability scanning in Go. All right, so let me take a look at the chat. All right, so if you have any questions, you can basically type them into the chat window. Let's see, I've got one here. Oh, okay. So this user is asking, do you have to use GoCenter to use the vulnerability scanning tool in VS Code? No, you don't have to connect to GoCenter. So we set up the VS Code extension to basically pull data from GoCenter, but the vulnerability information is provided to you for free in VS Code, so you don't have to connect to GoCenter to use it. You basically just download the JFrog extension from the VS Code marketplace. Okay. Next question is about if you want to build your project, and do you have to commit it to the checksum database? No, actually, it's a great question. If you are building a Go module and you want to keep it private, so there's actually two environment variables you can set. You can use Go private, and that'll basically keep Google from Golang from seeing the import path of your module. You can use DB, and that is going to basically tell your module not to push the code to the checksum database to verify it. So the Gosum DB will basically keep your module safe, or keep your module from using Google's checksum database, and Go private will actually keep the whole import path private. Okay, I don't see any other questions coming in from the chat at this time. If you guys have more questions, you can email me, or you can email the JFrog team at gocenter.jfrog.com. And I think that's it. So